Every other Juice Shop walkthrough on YouTube solves this challenge the same way. They open DevTools, they search for the word sandbox, they find a route, challenge done. That's not how a pen tester finds this bug on real engagement. Today we're going to walk into Juice Shop like it's a real client app. We're going to hunt for routes and endpoints the developers left reachable by accident, and by the end of this video, you will have a workflow that works on any modern day web app. Here's the setup. Juicebox has a challenge called Find an Accidentally Deployed Code Sandbox. The premise, someone on the dev team built a page where you can run code, probably for internal testing, and it's shipped to production by accident. Nothing in the UI links to it. From the outside, it looks like the page doesn't exist. We'll go to the scoreboard to take a look. We'll go to broken access control. And here's the one we're going to be working on right here. This is the forced browsing family of bugs which lives under A01 broken access control in OWASP top 10. A01 has held the #1 spot for years and is still #1 at the time of the making of this video. It's the most common category of findings in real engagements by a wide margin. We're going to use 4 tools today in this order. Burp Suite for the baseline, LinkFinder to extract endpoints from the JavaScript bundle, ffuf to enumerate what the server actually exposes, and browser DevTools to extract the client-side route declarations. Every engagement starts the same way. The app gets proxied through Burp, and you walk the navigation as a normal user. Burp's HTTP history captures every single thing the browser loaded. Every page, every image, every script, every API call. To really test the app, you first have to have a good understanding of how the app works. That's what we're doing here. Learn the app from the perspective of a normal user first. What we're building while we're browsing in Burp is our baseline. The list of URLs the app actually shows us while we're clicking around like a normal user. Hold on to this list. We're going to compare the rest of the tool's output against this list in a few minutes, and every difference is a potential target in your attack surface. To save time for the video, I'm not going to scan through every request and stop right here. I'm going to filter for JavaScript files. Juice Shop is an Angular application. In Angular apps, most of the front end lives in a bundle called main.js. And that bundle contains every route the application supports. What I want now is a clean copy of that bundle on my disk so I can hand it to the next tool. I'm going to right-click on main.js in the history, copy URL, then over in the terminal, I'll execute this command. That gives me a clean text file ready for the next tool. Burp's job for this part is done. It showed me what bundles exist and gave me the exact URL to grab. 3 things just happened here. 1, we built our baseline of what the app shows a normal user. 2, we discovered which JavaScript files the app actually loads. And 3, we pulled a clean copy of the main bundle for analysis. And we'll use this baseline to diff against every other tool later. Tool number 2 is LinkFinder. It's been around since 2017 and it's a staple in the bug bounty workflow. What it does is it reads JavaScript files, runs a tuned set of regular expressions over it, and pulls out every string that looks like a URL, an endpoint, or a path. It's a passive tool, which means it never touches the server, it just reads the file you pointed at. Now, we point at the main.js we saved out of Burp a minute ago. LinkFinder doesn't read Burp's history or talk to Burp, it just opens the file on disk that Burp gave us. Here's the command. Look at this output. Every URL string LinkFinder could find in the bundle. Some of these we already saw in our Burp baseline, but some of these we didn't. These are our leads to investigate. One important limitation to know about LinkFinder is it looks for strings that look like URLs, typically things with slashes. Bare route names like a web3-sandbox or administration, which are how Angular app declares its client-side routes, don't have slashes in them, so LinkFinder usually misses those. That's why we still need DevTools at the end. All right, now that we have that, let's save the output to a file so we can diff it against Burp or any other tools later on. There we go. All right, tool 3 is called ffuf. This stands for Fuzz Faster You Fool. It's a Go-based web fuzzier. Where LinkFinder is passive, ffuf is active. ffuf actually sends requests to the server with words from a word list and reports back which ones the server responds to. Together, the two tools give you the complete API picture. Passive tells you what the front end knows about. Active tells you what the server is actually willing to serve. They overlap, but they each catch things that the other one misses. Now we're going to go ahead and fuzz the server. I remember seeing REST and API paths in the burp baseline, so those are the two paths we'll target. Replace fuzz in the URL with words from the word list, only show responses that aren't 404s and aren't empty, and save the results to a file so we can diff them against LinkFinder later. That's the command you're seeing on the screen right now. All right, these are the endpoints under REST the server is willing to respond to. We're going to run the same thing against API. All right, you see all the challenges popping off? We've done good. So what you're seeing here is just another layer of information. Some of these match what LinkFinder found. That's good, that's confirmation of what we know to be true. Some of those are brand new. The ones that don't appear in either LinkFinder or in our burp baseline are the orphaned and legacy endpoints. The ones that the front end doesn't reference anymore, but the server still exposes. The reason we run both. LinkFinder catches what the front end references, but the server might have removed. ffuf can catch what the server still exposes, even if the front end stopped calling it. Now, the ffuf file isn't JSON and looks kind of ugly, but you can easily write a Python script to clean that up. I also have something at the end of the video that might make this whole process a bit easier for you. LinkFinder and ffuf together give us the API attack surface. They don't give us what's called the client-side SPA routes, or single-page application. Those bare string route names I mentioned earlier. For those, we need to look at the bundle ourselves in DevTools. Quick browser note, I'm using Firefox. The tab is called Debugger for me. Chrome and Edge call the same thing sources. Different tab, same panel. Open main.js, click the curly buttons at the bottom left to pretty print, and now we can read it. Here's the trick that beats the other YouTube tutorials. Instead of searching for the answer sandbox, we search for the pattern that declares the route. In Angular, every route is registered with path : followed by a string. So I'm searching for the literal text path : Every match is going to be a route declaration somewhere in the routing module. Firefox's debugger search supports regex, but the regex toggle isn't as visible as in Chrome. For this exercise, plain literal text search is fine and gives the same result. Depending upon how you like to work, you may not like this little screen. I'm just going to place all this in the Sublime text and search it in there. That's my preferred method. Step through every match. Most will be route declarations. Few might be other code references. Just ignore those. Note the route strings as you find them. The same approach works for every modern SPA framework. You just need to know how that framework declares its routes. Look up your target's framework on day one of any engagement and confirm the route declaration pattern used by that framework. Alright, now the actual work to diff our inventory against what's actually linked from the UI. To save time, I'm just going to start working from the main.js pull. In a real engagement, you would use all the lists that we collected today, but it would take too long to go through everything in this video. We didn't see a lot of visible navigation links to check when we were going through with Burp. Our DevTools search found way more in the bundle. That's the delta you're investigating. Routes that exist in the app, but aren't reachable from the menu. Every one of those is a potential finding. Every one requires a visit, so you can lay your eyeballs on the results. An example you need to know about would be this one, scoreboard. Copy and paste this in the URL and we confirm that the URL works. We can also see that LinkFinder reports the hidden page as well. The target we're looking for is sandbox, so looking in main, we can find reference to it. Take the first part, toss it in the URL, and there's the sandbox we were looking for. We can also see in LinkFinder where it found reference to that page as well. What else did LinkFinder and main.js show us? The real value of this workflow is what we also found: administration. And a handful of others you might find interesting when you visit them. Each one is its own potential finding on a real engagement. We solved one Juice Shop challenge. On a real client, we'd probably be writing up several issues that they need to address. All right, quick recap of the workflow so you can take it with you. 1. Proxy the app through Burp and walk it like a user. That's your baseline. 2. Save the JavaScript bundle you found in Burp to disk. Run LinkFinder against the saved file. That extracts every URL endpoint string the front end references. Diff against the Burp baseline. 3. Run ffuf against the API-based paths that you observed. That tells you what the server is actually willing to respond to. Diff against both LinkFinder and the Burp baseline. 4. Open the bundles in DevTools, pretty print it, and search for the framework's route declaration pattern. That extracts the client-side route inventory. Diff against the visible navigation. What you're doing across all 4 steps is the same operation. Enumerate what the app can do, subtract what the app shows you it can do, then you investigate what's left. Let's zoom out for a second. The reason this matters isn't that we found a sandbox in a deliberately vulnerable application. Anyone can do that. The reason it matters is to learn the workflow. Proxy the app, pull the JavaScript, run LinkFinder on the bundle, fuzz the API with ffuf, regex search the bundle for route declarations, diff everything against the visible navigation. If you're learning this craft on your own, run this workflow against a personal project, staging app on your own, or another deliberately vulnerable web lab. There are plenty of them out there. Juice Shop has many more challenges, and most of them respond to this exact recon. If you recall back when we were going through the recon, you saw a bunch of challenges start to pop in the background saying, hey, you found this, you found that. So it proves that the methodology has worked. The first pass on a small app should take about 30 minutes. All right, if you guys remember, I said I may have something that would make your lives a little bit easier concerning this whole process that we went through. I put together a little Python script, called it Bug Bounty Path Inspection. It uses, of course, ffuf and LinkFinder. It also uses regex to go into the app that you're trying to scan. It determines what type of web app it is, and then it does a scan to try to find the paths automatically. So if you run it, it gives you a full report. And you can see the report, the attack surface report, gives you the target you were working on, the architecture, the framework, tools used, the data was generated, base URL that you were looking at, source maps exposed when you're scanning the application, and then it goes through the work of doing the comparisons for you, so you don't have to sit there for 45 minutes and do it on your own. I'm not saying it's flawless, but I'm saying it works with Juice Shop, and I'm going to test it on some other apps and see what happens. But you can see here under unlinked SPA routes, you got 44 total that you'll want to look at. You see all the hyperlinks are right there for you. Just click on them and it'll open it up. You can copy as curl, and you can try it that way as well. But here's our sandbox that we talked about before, and you can see it's working just fine. Further down, it gives you more information about unlinked endpoints. And even further down, it gives you tool execution logs, just so you know what happened during your session. And all the very interesting things are marked to draw your eye to it. I'll go ahead and throw that up on GitHub. Again, no guarantees that's perfect. It's just something I put together real quick. Take it, use it, destroy it, make it your own, whatever you like. And that's it. Thank you so much for watching this video to the end. I hope some people found this information useful. If you did, please leave a like. It'll really help the channel surface for people searching for real methodology instead of just click path walkthroughs. I hope to see you in the next video.